Assalamualaikum Pak Dek.
Warahmatullahi wabarakatuh.
Mulai Pak Dekan ya.
Ya, baik, Prof. Jul.
Oke, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang, selamat petang. Salam sejahtera untuk kita semua. Good afternoon, Martin Doc. Now we are starting to open the general lecture. Pak Artono, the Dean, is now in the Sriwijaya campus. So he's joining our online, Zoom. Oke. Bapak Dekan, Bapak-bapak dosen, di sini ada beberapa dosen yang aktif yang datang ya. Dan yang online di sini ada Pak Supartono, ada Pak Budi Mulyono, Bu Habiza, ada Bu Weni, ya. Mahasiswa S3, hampir semuanya hadir kecuali beberapa yang dari luar kota. Saya lihat ada yang di Jogja nggak bisa hadir, di join online juga di Linggau ya, ada 2 orang. Bapak Dekan yang saya hormati, pertama-tama marilah tantinya kita mengucapkan puji dan syukur kehadirat Allah Subhanahu wa taala karena pada hari ini kita masih sempat bertemu, berkumpul di sini dalam rangka kuliah umum dari teman kita Profesor Martin Dolk dari Utrecht University. Sebagaimana telah dianjurkan oleh Pak Dekan dalam hal internasionalisasi, kita harus pandai-pandai memanfaatkan peluang, dan kebetulan Martin Dolk yang akan seyogianya hadir hari Kamis karena akan jadi keynote speaker di CDR tanggal 19-20, tapi kita ajak dia lebih cepat datang ke sini untuk memberikan kuliah umum kepada mahasiswa program pasca sarjana, khususnya mahasiswa S3 dan ada S2 di sini. Dan juga nanti setelah kuliah umum ini, Martin Dolk juga akan memberikan komentar kepada mahasiswa yang memberikan presentasi kolokium. Kolokium adalah mata kuliah di mana mahasiswa memfokuskan kepada konten disertasi, konten matematikanya. Dan besok rencana pagi akan diskusi tentang proposal ya, proposal yang disertasi yang akan dikerjakan oleh mahasiswa semester pertama ini, semester kedua ini. Kemudian juga Pak Dekan kami laporkan selain di kegiatan di Prodi Pendidikan Matematika, juga Profesor Martin juga akan melaksanakan kuliah umum besok siang jam 2 di program PGSD, Pak. Kebetulan saya bicara dengan Bu Dewi dan dia langsung menangkap peluang itu. Dia bilang sudah lapor dengan Pak Dekan dan Pak Dekan setuju ya. Jadi besok ada kuliah umum di program PGSD, yaitu tentang pembelajaran matematika di lower class ya, kelas 1, 2, 3. Nah, ini yang saya laporkan bahwa hari ini akan kuliah sampai jam 5. Mohon kepada Pak Dekan untuk membuka dan memberikan pencerahan ya pada kami semua tentunya. Hal ini juga disampaikan kepada Martin Dolk bahwa kami sedang melaksanakan persiapan untuk akreditasi internasional ASIIN Jerman, dan beliau juga tahu kan program atau tentang ASIIN. Dia bilang itu tidak mudah, keras memang, sama seperti dengan Belanda. Tentu harus banyak yang harus kita kerjakan dan tunjukkan kepada mereka bahwa kita betul-betul ada kegiatan itu. Itulah makna dari kegiatan hari ini Pak Dekan. Terima kasih juga kepada mahasiswa. Semuanya ini kegiatan mahasiswa Pak Dekan. Mereka menyiapkan, mereka menjemput. Bahkan kemarin alhamdulillah ketemu Pak Dekan, jadi Pak Dekan yang langsung membawa Martin ke hotel. Dan ini juga bagian pembelajaran dari mahasiswa calon doktor di FKIP Universitas Sriwijaya. Demikianlah akhir kata. Billahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Greetings to all of us. The Honorable, the Dean of the Faculty of Teacher Training and Education, Bapak Dr. Hartono MA, the Honorable, the Coordinator of Doctoral Study Program of Mathematics Education, Bapak Profesor Dr. Zulkardi MIKOM MSc, the Honorable all lecturers and staff of Mathematics Education Department, the Honorable all speakers of this general lecture, Dr. Martin Dolk, and also to the audience and this general lecture participants. First, let us say thanks to our God, Allah Subhanahu wa Ta'ala, to the Lord of the world, who has been giving us the chance to meet together in this occasion. And secondly, may peace be upon our Prophet Muhammad Sallallahu Alaihi Wasallam, who has guided us into the right ways of life. Ladies and gentlemen, here I am, Yona Adelia, as the Master of Ceremony of today's general lecture. Before we start our agenda, let us say Bismillah, Basmalah to start this general lecture. Bismillahirrahmanirrahim. And then the next agenda is the singing of Indonesian National Anthem. Please rise for the singing of National Anthem. Participants, please have a seat. The third agenda is greetings. The first greeting will be delivered by the chairperson of this general lecture, Dr. The first greetings will be delivered by the Dean of Faculty of Teacher Training and Education, Bapak Dr. Hartono MA. For Bapak Dr. MA, time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning. Shall our guest lectures, Professor Dr. Martin Dolk. Yeah. Good afternoon, I mean. Yeah, sorry. Yang kami hormati Bapak Ketua Koordinator Program Studi Doktor Pendidikan Matematika, Pak Profesor Dr. Zulkardi, Bapak Ibu dosen di lingkungan FKIP Universitas Sriwijaya, khususnya di program Doktor Pendidikan Matematika. Ada juga koordinator program studi S2, mungkin S1, dan tentunya banggakan mahasiswa S3 di program Pendidikan Matematika. First of all, I would like thank you for Professor Dr. Martin Doc that will deliver this afternoon. Already collaborate with the Utrecht University last year, December 2022. We extended the collaboration between Sriwijaya University and Utrecht University. I think this is very important to work with the Utrecht University since 2016 that we opened the doctoral program. Without help with the Utrecht University, maybe we cannot open this program, mathematics education doctoral. So this is the history that. So I say the appreciate with the scientific director Prudential Institute, Utrecht University, that help us to develop the doctoral program in mathematics education until now. So this collaboration we will to extend with the science education in future. These good challenges that open the other master program in education like biology education, chemistry education, and PhD program in science education in future with the collaboration with the Utrecht University. This a great plan, I think, and as I would like to thank you for the special for the scientific director of Prudential Institute, and of course with the Professor Dr. Martin Doc. He dedicate his experience, his knowledge to in the mathematics education, especially in Faculty of Teacher Training and Education University. Again, thank you for Professor Dr. Martin Doc. And for the student, I think this the good challenging, good experiences to learn from the experience from the Martin Doc, Dr. Martin Doc to his experiences in mathematics education in the world, especially if PMRI. So that we know that the journal of is the the biggest journal in the Asia and also in the world. So this our excellencies in mathematics doctoral program in Sriwijaya University that the journal can help our students to publish and the success study in the PhD program in mathematics education in Faculty of Teacher Training and Education, Sriwijaya University. So we will, of course, we will to promote the other journal to be the example, the JMA, Journal of Mathematics Education, and other journal in Sriwijaya University to be JMA. I think is very is good to know in the world that our lecture in Sriwijaya University in writing journal, writing article in the reputation journal. So we recognize Sriwijaya University are recognized in the world because of the journal. So I think this good moment, yeah, to interact with the Dr. Martin Doc, and this chance, please, student to interaction with the uh, Professor Doc, yeah, because it's very rare to this station, this academic environment. So please don't hesitate to ask something to Professor Dr. Martin Doc. As the Dean, with the Bismillahirrahmanirrahim, I open officially the general lecture this afternoon. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you for the greetings, Bapak Dr. Hartono. Okay, the fourth agenda is prayer, and that will be led by Muhammad Aidil Fitrisha.
Assalamualaikum warahmatullahi wabarakatuh. Sebelum memulai acara kita pada hari ini, marilah kita bersama-sama menundukkan kepala, bermunajat kepada Allah SWT. Semoga apa yang telah dan akan kita laksanakan akan mendapatkan rahmat, hidayah, dan keridhaan dari Allah SWT. Bagi saudara kami yang beragama selain Islam, silahkan menyesuaikan menurut keyakinan masing-masing. Auzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin, hamdan syakirin, hamdan naimin, hamdan yuafi ni'amahu wa yukafi mazidah. Ya Rabbana lakal hamdu kama yang bari jalali wajhikal karimi wa ajri bisultanik. Allahumma sholli ala sayyidina Muhammad wa ala ali sayyidina Muhammad. Ya Allah, ya Tuhan kami bersyukur atas segala nikmat yang Kau berikan kepada kami. Nikmat iman, nikmat kesempatan, serta nikmat waktu, sehingga kami masih memiliki kesempatan untuk terus belajar di usia yang telah Engkau tetapkan untuk kami. Semoga apa yang kami laksanakan pada hari ini dicatat sebagai amal ibadah di sisi-Mu. Allahumma ya Allah ya Rabbana, jadikanlah kegiatan kami hari ini sebagai majelis ilmu yang bermanfaat, guna menambah wawasan keilmuan kami, yang membuahkan hasil bermanfaat bagi kemaslahatan dan sebagai pendobrak kemajuan bangsa, serta keselamatan dunia dan akhirat kami. Ya Allah, berikanlah kami kekayaan ilmu pengetahuan, hiasilah kami dengan kelapangan hati, muliakanlah kami dengan takwa, dan berilah kami kesehatan. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Subhana rabbika rabbil izzati amma yasifun wa salamun alal mursalin walhamdulillahirabbil alamin. Wassalamualaikum warahmatullahi wabarakatuh.
Amin, amin, amin ya rabbal alamin. And the next agenda is a group photo. Maybe all the lecturers and the participants, we can gather right there to take a group photo together. Di depan sini boleh mungkin. Ya, sambil duduk gitu. Kalau misalnya di belakang penuh gitu. Okay, so the next agenda is what we have been waiting for, the general lecture from Professor Dr. Martin Dok from Utrecht University. But before we start, let me read his short curriculum vitae. Dr. Martin Dok is involved in the development and research of in-service materials and interactive support system for student teachers. His research interest also focuses on teacher knowledge and behavior in teaching situations. And presently, he is involved in mathematics education research program, specifically in Indonesia. Well, now to Professor Dr. Martin Dok, time is yours.
Pak Jul, izin keluar ya. Ada meeting. Oke.
Thank you. Thank you very much. I hear an echo. Yeah. Thank you very much. It's a pleasure to be in Indonesia. It's a pleasure to be here. I just realized that Professor Zulkardi and I probably know each other 25 years because you came to the Netherlands in 1998. And that must have been the first time we met, not knowing how much we would work together. 25 great years. I've been to Palembang a good many times. And of course, every time I meet different students. So it's great to meet all of you. Now, if you have seen me before, you know that I let you work. So you need paper and you need a pen. So before we continue, make sure you have some paper and a pen near you. And if you sit there, can you see the screen? Can you read the screen? Or is it better to sit a little further to the back? And is there a way to show my screen? Yeah. Can we show my screen? My screen on there. Instead of me, I appreciate it to see the screen. I don't have to look at myself. There it is. So, I want to talk about realistic mathematics. Now, many people think realistic mathematics is only in context. And I will want to change that a little. Now, saya tidak bisa berbahasa Indonesia. So I have to do it in English. But if you want things translated, tell us. If you want to ask a question in Bahasa, tell us. That can be done. So if I talk too fast, stop me, ask me, explain what I said, ask me to give more examples. If I'm too fast, tell me. That's the rule. So let's start with a mathematics problem. How many layers of tea lights are in this tea box? Sorry, in this box. How many layers of lights are in this box? Now, the problem of working with people is that as a teacher, you never know when you can continue. Because you want to continue when everybody had enough think time. So when I ask you a problem and you're done, nod at me, so I know I can continue. This is a problem that a colleague of mine, Truus Dekker, came up and she asked children. And in a classroom, then the discussion starts. There are children who say, I know those lights, they are this high. So there is only one layer. But then the neighbors say, it cannot be because there are 105 in the box. One is impossible. So the problem allows children to correct mistakes. It's not a teacher who have to tell, oh, that's wrong. Hey, you're stupid, that's wrong. The children can correct each other with the problem. Now, counting for a minute with your hands or with your eyes. And then, of course, you count upwards. 1, 2, 3. But what happens in the part that you don't see? There are children who say that's empty. So they say 3 times 7, then there has to be 5 layers. That's okay. Under the assumption it's a bit odd. Most children don't accept that. They say, well, then under that cover are probably also. So it is 6 by 7 is 42. Second layer, 84. Third layer, 126. Huh? What do I do wrong? They know themselves that something in their assumptions was. Hey, if there are not 6, but if there are 5, what happens? So 7 times 70, 105, yeah, got it. They feel good. But they could correct themselves in the problem. And a rich problem is not a problem where you manipulate it, but it's a problem where you have to make sense of what happens. Of course, it can be in geometry. So this is a problem that we developed for children in very rural schools in Bangladesh. And so the question is, what is the girl in white? What does she see? Does she see 1 or 2 or 3? And how do you know? Now, with children, they have to start understanding what it is to be in someone else's place. And that is difficult. And so they make a viewer by rolling a piece of paper, and then you have to start. And then, of course, with young children, you can also do that to them. So now the question is, where do I have to stand so that I see you and I see you at the same time? Well, I cannot stand here. But can I see it now? See it now? Can I see it now? But if I just try it, there's no mathematics. But if I stand here and I have to direct Axel to stand somewhere so that he can see it, and I can say, now I'm sure that you can see both, then I have to imagine how that works. I have to make an imaginary line between the two of you, and Azul needs to be on that line too. And I can now start explaining why I put Pasul there. Now, the difference between just doing and forcing children to build a kind of theory. And within realistic mathematics, we don't want just the solution. We want to go for a theory behind the solution. Now, look at the following. There is a slight delay between my screen and that screen, and I never know if my screen wants to go forward or not. Okay, it's coming. Compare those two problems. Talk to your neighbor. What is the difference between the problem on the left and the problem on the right? Which one do you like better? What will happen if you ask children to solve these two problems? What is the mathematics that will happen? Talk to your neighbors. So, in a classroom, when I start a discussion, I might say, who had an interesting neighbor? Or I might ask, who had a partnership where you disagreed? Because that is what is interesting. If you both think the same, it's not interesting. So, here, who had an interesting neighbor? Who had a neighbor who said a couple of things that were new to you? Who likes to share? Now I wait.
Oke, jadi pertanyaannya mungkin untuk didiskusikan. Jadi dari dua pertanyaan yang sebelah kiri dan sebelah kanan itu kira-kira mana yang Bapak Ibu pilih untuk dibahas di kelas gitu? Kenapa? Kira-kira yang mana yang lebih engaging mungkin gitu buat siswa? Pertanyaannya gimana? Kira-kira seperti itu mana dan kalau misalnya pertanyaan yang kiri misalnya yang dipilih kenapa? Kalau misalnya pilih pertanyaan yang kanan gitu kenapa? Nanti jawabnya boleh pakai bahasa Indonesia dulu.
Let's talk in the whole group. So who likes to share some of your thinking?
Jadi siapa ya ada Bapak Ibu yang mau share opininya, pendapatnya?
Well, I discussed with and also with Tia. Ellie and I chose the car problem instead of the shoes. I think the shoes problem is just merely counting, but in the toys problem, it is students can build some theory regarding to the discount. They will realize that if a store has a bigger discount, 75% here, then they will pay less than the another store that has lower discount.
Saya mau menjawab dengan bahasa Indonesia. Tolong Fiona. Kami telah berdiskusi dari Mbak Mala sama Arvin memilih toy car karena di situ kan nggak tahu harganya berapa. Jadi kalau nggak tahu harganya berapa, jadi belum tahu yang mana diskon yang paling besar antara toko A dengan toko B. Kalau pada sus store udah tahu harganya, jadi tinggal menghitung aja gitu.
So basically the answer is the same from Miss Septi. Jadi for the for the right problems, there is no price for the toys. So so students have to maybe guess or maybe build a theory like if the discount, the number of the discount is bigger, then they have to pay less. But the left problems. They just have to count like the price is already there.
Thank you. So I'm discussing with Priya. So we prefer to choose the right one because in the right one there is no information about the price of the toy car. Instead of the left one, there is information about the price of the shoes. So this problem, the right one is kind of open-ended question. For example, our student can predict the price of a toy car. So there are a lot of answer. Like I said before, it's kind of open-ended question. For the left one, it's closed-ended question. They just count the price of shoes in each store, and then it's built. They're logical about the price of the toy car, and then the discussion more interesting for students. They they need to know about the concept of the discount. When they got discount 75%, they need to pay 25% of the item.
Thank you. Let me see hands in the problem toy car. Who says I buy at store A? Who says I buy at store B? I want to see hands. I try over. Raise your hands. Who wants to buy at store A? No hands. Okay. That's clear, because then who wants to buy at store B? Okay. What if I tell you price for that car at store A is 1 million and at store B the price is 2 million? You only know the percentage if you know the whole. And if you don't know what the price is, you don't know which store is cheaper. That's the difference between absolute and relative. And you have to know when you have to look at absolute and when you have to look at relative. And so what children do is that they first are like you. Oh, store B. And then slowly one of the children start to talk about prices. And now, of course, I can say, so by what prices, what would the price of the toy car in A and B be that you pay the same? When do you pay less at A? When do you pay less at B? So all of a sudden, you talk about the big idea. You need to know the whole, but you also talk about the calculations. Now the problem on the left is only calculation. When I look at your paper, you had a lot of calculations on the left, and on the right was empty. And that is where the discussion is. So that is the difference. You've been sitting now for an hour, so a little gymnastics. And it's interesting because that screen is slower. So you see the red dot. That red dot move to 0. I want you, it's not moving yet. It will go. I want you to sit down when the red dot is at 1 Utah. That needs translation.
Jadi yang titik merah itu kan ada di 1 miliar, jadi kita diminta untuk berdiri. Kira-kira titik merahnya ada di mana kalau angkanya itu 1 juta. Duduk. Duduk. Disuruh duduk. Pas 1 juta duduk gitu.
I hope it's going, but with the delay I'm a bit unsure what happens. There it goes. In the middle it goes a bit faster. We have 1 person sitting. We have 3 people sitting. We have 5 people sitting. If you were a mathematician, I would have said, is it the same if it was a logarithmic scale? Because you didn't ask me what the scale was. But if it is a linear scale, then, of course, 1 Utah is 1,000 thousands of a milliard. So if I divide in 2, I have to do that 10 times. So I divided it once. Very interesting. Yeah, you can see it. And now I divide that again in 1. And I divide it again. And again. And you see how close that gets to 0. In reality, you don't see the difference between 0 and 1 iota. It is so close. But that number sense is a number sense that is very difficult for your students. Because you were thinking. But many of the students don't always do that. And you need a lot of number sense here. Of course, I didn't ask the students any calculation. I didn't ask, they had to find out what they had to think themselves. So let's see how your number sense is. I'd like you to solve these problems. You have paper, please solve these problems. Stop for a minute. Pen down, pen down. Most of you, very impressed. When I asked the first problem, this is what many students will say. 3 and 8 is 11, 3 and 9 is 12, 3 and 9 is 12, 3 and 4 is 7. Students can make mistakes where the place value is really off. Somehow they didn't understand the algorithm that the teacher told them. And I don't blame those students because the teacher never had them discover what that. The students didn't invent that algorithm. The teacher told them, follow me, do this. So that, of course, is wrong. But putting it column-wise underneath each other is a very time-consuming approach. And I was very happy to see that quite a number of you did things like this. Plus 5,000. Because then I don't need a calculator. The calculator is even taking too much time. And of course, I had chosen these numbers so that you could do it easily. Now, just look at the problems and just think for yourself, how can I solve these problems handy? Can I solve the problems without that algorithm that the teacher taught me in primary school? Can I solve the problems by looking at the numbers? So, very short time to look at those problems. Okay, let's look at those problems, because they are not so difficult, and if you're not able to solve them, you wouldn't be here at the mathematics department. So I know for sure that you can solve them. So one way to look at the first problem is to say, I make a jump of 5,000, but then I have added 5,000. I don't need to do that. I need to make a jump back of 2. With all this thinking, I am always representing my thinking in a drawing, in a model. I represent what I'm doing. I work with children, I will do that on the board. Oh, you said you first added 5,000 and then you withdrew 2? Is this what you did? So models are very helpful for children to understand what happens. And of course, I could have written it in a more mathematical statement, but that is much harder for children to really comprehend. A model represents almost the same. And if I now write a statement, and the children can see how the statement is related to the drawing, to the model. Now, the second problem, you could say, if I draw it, that 2,998 and 3,002 are very close together. So if I make a jump of 2 and I make another jump of 2, I'm done. But putting 3,002 minus 2,998 underneath each other is torture for many children, and it will lead to a lot of mistakes. And this has to do with the fact that subtraction can be seen as 2 things. It can be seen as removing 2,998 from the 3,002, but it can also be seen as the distance between the 2 points. And if children never see those 2 interpretations, it's hard for them. Now, the next one, I can also make a nice drawing. 120 mile 999. I call for it. That is, it's 1,000. It is 120 times 1,000. Yeah, I have to remove 1 strip of 120 by 1. So it is 120 times 1,000 minus 120. So I do a multiplication by only doing subtraction. This goes so much faster. And it is more fun. Because now all of a sudden I can talk with my neighbors about, how did you do it? And if it is really difficult, then indeed there is always the calculator. So 400 divided by 16. When I write it, I can write this. Because division and fractions are related. And so I could say the fraction 400 over 16 is the same as the fraction 200 over 8 is the same as the fraction 100 divided by 4. But if I don't see the relationship between fractions and division, then 400 divided by 16 is long division with all the errors. If I want to draw it, I can draw a rectangle. And I say the surface area is 400, one side is 16, what is the other side? But if I halve that, I have 200 as the surface area and 8 on the side. If I halve that, I have 100 as surface area and 4 on the side. All those fractions, all those divisions are the same. And if I'm able to look at dividing and to look at fractions also in the form of a model, that helps me to understand why certain procedures work or not. Of course, I could have drawn the rectangles slightly different, separate from each other. It would still be the same representation. And so doing this kind of problems only in an algorithm is not helpful. You will have to find models that help children. You will have to find context that helps children to understand it. And you will have to find the relationships, in this case, between division, fractions, decimal numbers, etc. And the last problem, 257 minus 139. I could also say 258 minus. I could even go to 168 minus 150. 318 minus 200. They are all the same problem. And if I look at it on a number line, this jump between 139 and 257 is the same jump between 140 and 258. I just moved the jump one place. And so working with models is extremely important. And I always say, when you first look at the numbers, you regularly can make many problems easier. Are there problems that are very hard, where you do need algorithms? Yes. Is that what mathematics represents? Not automatically. I want children to become thinkers. I want children to start thinking about what it is. And so, realistic mathematics, when I talk about it, I talk about models to think with, I talk about strategies, I talk about big ideas, and I talk about contexts. And those terms you will hear me say over and over and over. So when I looked at a textbook here in Indonesia, an example that they had came from the problem 1200 plus 2900, 1200 plus 2900. And they represent it with multi-based arithmetic blocks. In general, students don't understand multi-based arithmetic blocks. They don't know how it works. You need to understand place value to understand those blocks. So I wondered, why not use money? A lot, but not all students know how money works. And 1200 and 2900, you can work in money. And many students, not all, many students know that 10 coins of 100 is equivalent to 1 coin of 1000. So this problem, instead of a meaningless multi-base arithmetic block, could be done with a little more meaningful money. The mathematics behind it is that they split 1200 in 1000 and 200. They split 2900 in 2900. And they add the thousands and they add the hundreds. What is sometimes a beautiful strategy. And you can calculate every addition in that way. Sometimes a lot of work, but it works always. So the strategy behind it is beautiful. We just don't like the representation. And the representation could also be done on a number line. 2900, I first go to a landmark number. 3000. Oh, 3000, 1000 more. 4000, 100 more. 4000, 100. Where is the 1200? And students have to look for that for a moment. It's important because we said 2900 plus 1200. So where is the 1200? But a representation on the number line could be a very meaningful representation. So in realistic mathematics, I'm looking for interesting problems that allow for investigations, problems that allow for discussions about big ideas, problems that allow for modeling. And not always. There are problems that are different. But in this case, if you look at the tree, a number line A, splitting it in thousands, C, of doing the standard column-wise addition, B. And the interesting thing for us as researchers is to really wonder which of these representations is meaningful for children. And how do I know that? Which of these representations is a representation where children make less mistakes? What is a representation where children understand what they are doing? What is a representation where children can explain to me why it worked? And so offering different solutions is nice, but there is a lot of research that needs to be done to know which one is better. Now, enough talking on my side, some thinking on your side. A problem that is a little different. Different people came up with this problem. So, in your head, draw the next 6 beats. What are the colors of these beats? Yeah. No.
Blue, blue, red, 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 blue.
Blue, blue, red, 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 blue. Because you saw there's a structure of 5. And another structure of 5. And the 5 is blue, blue, red, red, red. Okay. Not so easy if I ask you this. What is the color of the hundredths beat? Okay. What is the color of the hundredths beat? How do you know?
Because the color is blue, blue, red, red, and red is 5. Then 100 divided by 5 is red. Plus is red.
You use division? It's just about beats. You use division? Who did it differently? Who had a different argument? Sorry? Who had a different argument?
blue.
Bits is red. If 100 bits, it's red too.
So if the tens is red, then the 20th is red. I make jumps of 10 and every time it is red. So it is a different solution because division and making jumps of 10. And the nice thing is the students will bring in the mathematics. There is no mathematics on the board. The only question is what is the 100th beat? But the students will mathematize. What is the 100th beat in this one? All right. All right. Let's begin with a show of hands. There are two options, red or blue. So let's raise our hands if you think it is red. Of course. Who thinks it's red? Who thinks it's blue? Who needs more time? For a teacher, that is very important. Now, you knew I was coming to you.
In bahasa, ya. di layar kan warna merah yang terakhir. 10 pertama itu warna biru. Ya, karena dia ke 100 berarti untuk selanjutnya dia sampai 100 itu tetap biru kayak itu.
Blue? What's that? No. No. Oh. You can do it. Okay. Come on.
The pattern is 7. Pattern of the number is 7. Of the number.
I repeat what you say. The pattern of the number is 7. Who can explain that? The pattern of the number is 7. What does she mean? What does she mean by that? Normally in a class, you allow her to finish. But the pattern is 7 is crucial in understanding this problem. So that is where, as a teacher, I have to stop teaching and I have to say to the other people in the class, can you explain that? What does she mean by the pattern is 7? Who can say that? Who can put in your words what she means by the pattern is 7? She can do it. He can do it. But who else? You can.
We can see iteration here. Iteration here. The other word is iteration after 7 beats, and we can say the same pattern. Yeah, and then we can say the same color, or we can say it have the same pattern. I call it iteration.
Seven, it repeats itself. How does that help you to find 100?
I count the pattern is 7. Is so 7 times 10 and 70, and then 7 times 4, 28, and one more is the blue one.
So, if the pattern is 7, and that means that 7 is red, then the 70s is red, and the 91 is red, and the 96 is red. So 99 is the beginning, that's blue, and 100 is blue. Why does it not work with the tens? What we did earlier. Why do I have to do it differently here? Yeah, that has to do with the pattern, and it has to do how it repeats itself. So all of a sudden, in this problem is no mathematics. All of a sudden, we are looking at patterns, kind of geometry, and at the same time at multiples, and we are looking at the size as the length of the jumps that we make. And children can really argue about these things. Now, these are of course very rich problems. Early algebra. So 7x plus a number has to be 100. if you want to do it as algebra. You can look at it differently. I've heard people who don't like to start because they don't like that single one. So they said, I forget this part. I don't start at the 7, I have 5. And then I have a nice 7. And I have a nice 7. Hey, 5 plus 7x. And I have to go. So 96. And then I have to add 4 more. There's not one solution, there are many different solutions. And it is the richness of this problem that allows people to talk about it. So let's look at another one that my colleague Martin came up with. He just changed it slightly. Martin Kind says, okay, I talk about blocks. And 1 is blue, 2 is purple, 3 is red. 4 is blue, 5 is purple, 6 is red. Of course, I can now ask you what is the hundreds or the thousands. I'm not going to ask you that. Martin Kind asked the following question. No, sorry. I said the following question. Find a 5-digit red number. 5 digits. 37,259. That is 5 digits. Find a 5-digit red number. Go ahead. So what Martin Kind asks, of course, is what is the characteristic of multiples of 3? And you can look at that in a complex way. You can let's write down a number and see if it is a multiple of 3. But you can also approach it at an easy way. 3, 3, 3, 3, 3. Did I say 5 times? I think so. 33,333. 99,999. And as soon as you do that, then you look at this problem from a different perspective. You talk about the multiples and the characteristics of multiples. And that is easier than trying to see if 3,740,419 is a multiple of 3 or not. You approach the problem in a different way. Now, and I hope this goes well, I want to look into a classroom. And I was talking to a few of you yesterday, and we were talking about fractions. So I have 2 short videos about fractions, where a teacher talks about, in one case, addition, and in the other case, multiplication of fractions. And this is not, the first one is not an investigation. It is what we call a mini lesson, a short, quick lesson where you investigate some addition of fractions. But the teacher does it by giving a context. So I hope it goes well.
Some of you guys know from talking to me about where we live in the city and stuff that I live on the Upper West Side, really close to Central Park. And recently, I decided I needed to start exercising more. So I decided I'd start running in Central Park. They have that, seen the loop in Central Park there? You've been to Central Park, right? And when I decided I was going to start running and talking to people, a lot of people had advice for me about how much I should run, how much I should walk, should I do a combination of both. Alex suggested that I start by running for a third of an hour, and then I walk for a fourth of an hour. And I was wondering if you guys could tell me how much time that would be. Dylan.
That's 35 minutes, because 1/3 of a mile, 1/3 of an hour is 20 minutes, and 1/4 of an hour is 15 minutes, and 20 plus 15 is 35.
How many of you guys solved that in a similar way to Dylan here? Oh, everybody? Anybody think of it in a different way? Corey?
I kind of did it as like what times the denominator, which was 3 for the first one, would give me 60, because 60 minutes is in an hour.
Okay.
So 20 times 3 gives you 60. So that's how I got 20 minutes. And then 4 times 15 gets you 16 minutes, 60 minutes. And that's how I got 15.
So you thought that 3 times what equals 60? Mm-hmm. And you thought 4 times what equals 60? And that ended up being, for this one, 20 minutes. And for this one, 15 minutes?
Mm-hmm.
And then you put them together to get the 35 minutes again? Anybody think about it any differently? No? What portion of an hour? What part of an hour is that? Lucy, what do you think?
I think that it would be 7/12 of an hour. It can also be 35/60 of an hour, but it's easier if you reduce it. So, and I thought of it in 5-minute chunks, and each 5-minute chunk would be a 12th.
So if you were looking at a clock, and there's our center, and 12 was up here, and 3 was up at 5-minute chunks like this,
Yeah.
and you thought that a 5-minute chunk was 1/12 of an hour? Okay. So when we're looking at the clock, we think of the 6 being here and the 9 being here, and our first fraction was 1/3 of an hour, and you're saying that that was equal to 20 minutes, so that would be right about there from our 12. And then we've got another 1/4 of an hour on top of that, and you said that that's another 15 minutes. So there's another 5, 10, and another 15 minutes. So that goes all the way over to there, which ends up being our 7/12. Is that what you were thinking? Okay. All right. Now, Jess had some different advice for me. She said that I should run for a half an hour, and then I should walk for 2/3 of an hour. So I want you to think about what part of an hour that would be for me here. Just give me a thumbs up when you've got an answer for that. Andres, what do you think about that?
I think it's okay. I think it's I forgot.
That's all right. Victor, what do you think about that?
I think it's 70 minutes, 1 hour and 10 minutes, because a half an hour equals to 30 minutes, and 2/3 equals to 40 minutes. So an hour, I thought of it as an hour is 60 minutes, and if you take away the 10 from the 40, that would equal 60, and that would be an hour over.
If you take away the 10 from the 40.
Yeah. 30. From the 40 to make it 30. Yeah, and you're adding
30. Oh, I see. If you were thinking of the 40 minutes as 30 minutes plus 10 minutes?
Yeah, and then those two, the 30 minutes, the original 30 minutes plus the 30 minutes from 40 equals 1 hour. Then you still have that 10, which is an hour over, so that's an hour and 10 minutes.
So altogether that equals 70 minutes or 1 hour and 10 minutes. Here we had 30 out of 60 minutes, and here we had 40 out of 60 minutes, which altogether gave us 70 out of 60 minutes, or 1 and 10/60.
the children use the time as, let's say, a mediating number. They use minutes. The teacher has to ask sometimes, so what part of an hour is it? But there is no moment where those children look at it as just fractions. They know half is 30 minutes, a quarter is 15 minutes, and I can add up in the world of whole numbers. So, if you look at a double number line, and you have the hour on top, and you have the minutes on the bottom, those children are living in the bottom line. They think in minutes. And the only thing that needs to be done, and that is what Joel constantly asks for, is, hey, translate it to the top. Tell me what part of an hour that is. So the children say, in the first problem, a third of an hour is 20 minutes. And then I make a jump of 15 minutes, that is 35 minutes. So 1/3 of an hour plus 1/4 of an hour is 35 minutes. But what part of an hour is that? And then they come to 35 over 60, but that other girl was not looking in 60, she was looking in groups of 5 minutes. And so she was dividing it in 12s, and she came to 7 over 12. Why? Because the minutes, the context, the hour is so meaningful for children. And of course, a third and a fourth is difficult, and it is meaningless, and children make a lot of mistakes. But by bringing it in a meaningful world for the children, a world where the children can use their common sense, all of a sudden they're able to solve all these things. And with adding of fractions, the trick that you learned, I have to multiply 1/3, I have to multiply with 4, and children then say it is 4/3, not 4/12, or they go to 3, they make all kinds of mistakes there. But here, they don't use a trick, they use the context itself. And that is where the power is. And the representation on a double number line could easily be the good representation. Now, I want to look at one more. So I will let you listen to the teacher. I give you a moment to think about how would you solve this context, this problem, this investigation, and we listen to one group of children. And we see the teacher talking to that one group of children. And the mathematical problem, 2/5 of 3/4 or 3/4 of 2/5. That is the mathematical problem. But you know by now that that is not what a teacher will talk about. The teacher will make it into a context. And she will try to create a context that is meaningful, where children understand what is happening. And if not, she will help the children to understand it. And where the children kind of say, oh yes, I want to investigate that. So let's listen to the teacher. We need to switch sounds again. Padueno. Padueno. We need to switch sound again so that it's on the video.
This in your neighborhood, but the problem is that Brooklyn is a really big borough and there aren't that many little parks. There's not that many places to play basketball or to play kickball or just sit on a bench sometimes in the summer. So the good news is that in 2 neighborhoods in Brooklyn, they're thinking about developing some parks. And one of the neighborhoods is called Carroll Gardens. Have you heard of Carroll Gardens? No? Okay. Carroll Gardens is in Brooklyn, and there's an empty lot in Carroll Gardens. And the lot measures 50 yards by 100 yards. So it looks something like this. I used graph paper to model, and I'm counting 5 squares to model that this would represent 50 yards. I'll write that on there. And this dimension of the park, or the lot, represents 100. And it just turns out that 100 yards is about the length between 2 streets. It's about the length of a block. So this is kind of the dimensions of the lot.
She talks about 2 blocks. 1 block 50 by 100, 1 block 50 by 100. So the blocks. Now, in the next problem, in the next video, we are going to listen to her question.
This morning we're going to work on a problem. And here's what they've decided in Carroll Gardens. They said of this lot, 3/4 will be devoted to a playground for children. So let's write that. Okay, you can kind of imagine that. And then of the playground, 2/5 of the playground will be covered in blacktop, places where you and I can play basketball and kickball and things like this. I'm going to call that blacktop. That make sense? Oh, that's the situation in Carroll Gardens. Now, in another neighborhood in Brooklyn called Flatbush. Have you heard of Flatbush? Yeah. Okay, me too. The lot is actually the same size. Interestingly enough, it's an empty lot. There's nothing there at the moment. The lot measures 50 yards by 100 yards. But the discussion in Flatbush is a little about the playground. They've decided in this neighborhood in Flatbush that 2/5 of the lot they'll devote to a playground. And of the playground, 3/4 of it will be covered. So there's a bit of a question in terms of where, in which park, would you have more space for blacktop, more space to play basketball and kickball. It may be that the parks are the same in terms of blacktop. It may be that one park is a better option. It's our job today, and really we're helping kids in these neighborhoods figure out where are they likely to find more blacktop space.
So in this park, of the lot, here 3/4 of the lot is playground. The other 4, pond, grass field for mothers, parking lot for fathers. Can I be more sexist? I don't know. Maybe that other 4 is full of trees. But 3/4 is playground. Now, playground is where babies can play, where older children can play. So not the whole playground is for the older children. Only 2/5 of the playground is asphalt. That is where the children can play basketball. In the other park, 2/5 of this lot is playground. And 3/4 of the playground is blacktop. And so the question is, in which of those 2 parks there is more blacktop? Where's the more asphalt? Where can these 12-year-old children play basketball? Yes, I would now say, who that problem? So who the problem in Malta? Who thinks I can repeat the problem?
Oke, jadi teman-teman ini tadi ada dua tanah ya, dua kebun, dua taman. Yang pertama itu luasnya sama-sama 50 kali 100. Taman yang pertama 3/4 dari tamannya itu akan dibuat playground. Cara yang lainnya ya bebas mau ditumbuhin pohon atau mau untuk parkir dan lain-lain. Dari 3/4 bagian itu tadi yang dijadikan playground, 2/5-nya itu akan dijadikan tempat bermain basket. Jadi lapangan basket gitu ya. Terus sementara di tanah yang kedua 2/5 dari tamannya itu akan dijadikan playground. Dari 2/5 bagiannya itu 3/4-nya itu akan dilapisi oleh semen yang mau dijadiin lapangan basket. Nah pertanyaannya, taman mana yang memiliki blacktop yang lebih luas? Gitu.
Work on it 5 minutes. In 5 minutes, we are going to look at 2 children at work. So I want to listen to the teacher talking with two children. They have not yet solved the problem. They're in the middle. Here you see the teacher, and you see one of the two children.
And 2/5 are playground.
Three-fourths. And then it says the...
Well, let's back up. Did you shade in 2/5 of their lot?
I start over.
This out. Charlene, check this out. If this is the Flatbush lot and 2/5 are playground, did you finish the drawing?
No. Oh, no. The three-fourths. And then it says the...
Well, let's back up. Did you shade in?
No, because the whole thing would be 2/5.
Yeah.
But I would do the... I forgot to do the three-fourths. I should have done the three-fourths first.
I wonder if that matters. In this case, you did the 3/4 first because you were looking for the playground first, and then you kind of covered it in blacktop. You could do the same thing here. You could start with the playground first, and then cover it in blacktop.
But in this case, this one is the playground.
Yeah, exactly. But well, my question is the playground finished? Does this represent the playground?
2/5 is the playground.
Yeah, it is finished.
Does this represent 2/5?
These two are missing.
Let's fill them in, no?
No, because then 3/4 of the blacktop would be this. The 3/4 of the blacktop would be this. And then it said 2/5.
Okay.
Playground is this. So they kind of switch.
Say what you mean by that, Charlie.
Because at first this one, the whole thing was right here was playground, and then this was the blacktop, 2/5. But now in this case, the 2/5 are the playground, and then now this is the blacktop.
Yeah. Okay, well, I think it might make sense to show the whole playground, and then, like what you did here, cover the playground in the blacktop area. So I think
we're gonna uncolor like that, and then color the rest
with the black.
I'm not sure this represents 2/5 of the lot.
The whole thing would represent 2/5. So we colored these two in.
Yeah. So let's think about why are we not coloring these two in?
because
So the children where the heck? Yeah. The children, you can see a couple of things. The children subdivided both lots in 20 equal pieces. That helps to later say it's 6 out of 20. They don't find the 20 because of the multiplication algorithm. No, they find the 20 because of the context. But to do that, where they did it right in the first one, they kind of get lost in the second one. And then you see that the teacher is not telling them, listen, Pasul, you have to do this and that, do it now. No, the teacher is not telling them. The teacher starts a dialogue. At one moment, the teacher says, I don't know. Because what the teacher wants is that they start to talk about what they are doing, how it works. And you see the boy looking at the problem on the board and trying to understand where in their representation the blacktop and the playground is. Because he has to make sure, blacktop, playground, what is what and how does I represent it. In the drawing on the right, on the screen on the right, you can see those 3/4 and you see the 2/5 of the 3/4. But then you also need to see that in the other drawing, and they are not there yet. And the teacher, the role of the teacher is to talk with them to see how far are you. The role of the teacher is not to tell them what to do. The role of the teacher is not to tell them the algorithm. No, the role of the teacher is knowing that if they start drawing the 3/4 of 2/5 and the 2/5 of 3/4, they will start seeing the 6 out of 20. They don't know the algorithm, but the model is powerful. And the model can be used with multiplication of fractions everywhere. But then they need to really understand this model. And that is where this teacher is working on. And so, to talk about social norms, what started with Paul Kopp, in many classes, when one student understands it, the teacher assumes the whole class understands it, continues. In these classes, the norm is different. If one student doesn't understand it, the teacher thinks we have to talk about it. That's a totally different classroom. Most classes I see in Indonesia are on the left. And it's very difficult to change that to a classroom on the right. It takes time. It's extremely difficult. Bu Ratu Ilma wrote a lot about social norms. And I'm sure she talks with you about it. What you saw the teacher do is a conferral. The teacher wants to understand what the students are talking about. Help me understand what you're doing. Is that what you are doing? Oh, if I understand you, you now say this and this and this. It's a dialogue where the students explain what they do. And if you really want to do it, then you should celebrate with the students. Oh, that's great thinking. Oh, that will be helpful. Do you think you can tell others? And of course, we are never satisfied, so now I have to ask a question at the edge of their understanding. I have to ask a question that pushes them further. And that question will be different with each of the children. There is not one question, but it will be different questions, because students do something different. And so, when you look at realistic mathematics, you often see a series of investigations that contain all kinds of suggestions, that contain all kinds of constraints, difficulties, to make sure that students work on big ideas, they work on strategies, and they work on models. And I've shown this often, but from the students who went to the Netherlands, Frans van Galen and Dolly van Eerde made a small booklet with some ideas. You can download it, and this is the Indonesian version. There's also an English version if you prefer that. This is a booklet with some ideas of an investigation you can use, that you can give to other people, but might even lead to ideas for yourself. Professor Zulkardi, I stop here.
For me, this general lecture is more like a flashback to the moment when I was studying in Utrecht. That's what we did there. We analyze how students thinking and what strategies that they might do to solve some problems. I feel like going back to the 10 years old ago. Thank you very much, Martin.
Ya, saya sampaikan dengan bahasa Indonesia, Bapak. Yang saya dapatkan pada kuliah umum hari ini adalah bagaimana mengaitkan pembelajaran itu dengan kehidupan sehari-hari yang betul-betul dekat dengan siswa. Apalagi tadi tidak terfikir oleh saya pribadi mengajarkan pecahan dengan konsep jam. Jadi kalau kita selama ini mungkin ada pizza atau apa, ternyata tadi lebih apa? Real lagi tadi dengan konsep jam 30 menit, kemudian seperti itu. Jadi lebih dari 1 jam gitu kan, misalnya lebih dari 60. Kemudian tadi menggunakan apa yang posisi ya posisi dari 1 ke 1 miliar, kemudian dan itu juga ada konsep pecahan di sana seperti itu, dan itu sangat menarik. Demikian Bapak.
So based on Ibu Tria opinion about this general lecture, the first thing is how to connect mathematics into two realistic situation, so that close to students. For example, like teaching fractions through clock, through a watch, because we sometimes only teach fractions through pizza, through something circular, but by teaching them through using a watch, using a clock, it's more meaningful for students. And also the line where when it touch 1,000 we have to see. It's also very interesting based on Ibu Tria opinion. From her.
Terima kasih, saya akan menggunakan bahasa Indonesia. Jadi hari ini kuliah umumnya sangat luar biasa, Prof. Yang tadi belajar apa manik-manik, semuanya pola itu sangat luar biasa. Tambahkan dari Bu Tria tadi, penambahan yang 3 ditambah 4 9 itu sangat luar biasa, Prof.
It's basically all of the problems that you have given before. It's really interesting, really like we learn. She learns a lot of new things, like how to teach addition in a fun way, maybe. There's a lot of procedure that students can do to add, for example, 3,333 plus 4,998 in a fun way, not only in a procedural way. That's all about her.
Prof. Pertama saya ucapkan terima kasih. Menurut saya yang paling saat buku teks SD Prof, kan ada langsung anak saya prakteknya. Jadi kalau di sekolah itu memang dia mempraktekkan pakai balok-balok itu disusun, terus siswa buat sampai 10 ratusan. Kenapa nggak pakai hitung? Jadi memang anak saya kalau menghitung uang itu lebih cepat daripada dia menghitung angka gitu. Jadi kalau uang tuh kasih berapapun dia bisa langsung menghitung gitu. Tapi kalau pakai balok seperti itu lebih lama. Dan yang menarik lagi yang kedua, norma sosial tadi, interaksi antar siswa dan guru tadi Prof. Jadi bagi saya yang nggak belajar pendidikan Prof ya, jadi memang bukan hanya untuk SD tapi untuk sampai ke jenjang mahasiswa tuh interaksi dengan siswa itu sangat penting. Dan menurut wawancara dengan mahasiswa juga itu yang dibutuhkan. Jadi bukan hanya sekedar perintah, tugas atau teori-teori tentang matematika, tapi diskusi itu lebih penting daripada materi.
Based on her daughter's her school taught them to count by using the blocks, the cube, and however, her daughter understand well by using money. So the money context is very meaningful for her daughter, and also the social norms. It's a really important. Is a really important things for us as a teacher, as an educator, so that the interaction between students and teachers, students and a lecturer can be more meaningful, something like that.
Baik, Bro, mungkin nanti saya minta untuk Adele untuk mentranslitkan ke dalam bahasa Inggris. Jujur saja tadi pada saat Martin memberikan materi itu kayak jadi terbuka satu pemikiran bahwa kalau selama ini kita itu belajar matematika itu selalu diberikan rumus. Jadi dengan Martin tadi memberikan materi bahwa situasi atau kontekstual, keadaan yang kontekstual itu sebenarnya dapat menimbulkan strategi-strategi pemecahan masalah dalam
So based on Mbak Rahma opinion about this general lecture, we usually as a mathematics teacher taught students to learn mathematics through a formula. However, it is more meaningful for students if they learn from a meaningful context, such as the money, then the beats. Yeah, it's more meaningful for students rather only taught them by a formula.
From this general lecture, I got new insight about how to select good context as starting point in learning, such as and this good context is really meaningful if we can construct it with a meaningful activity. And I also note about how to teach mathematics only topic, but also it's with other topic. And yeah, how to teach us the way you in the student who wants to answer or of the problem. It's also important, like Ibu, that we can use the students who struggle with
Okay, so that's all from our general lecture for today. Thank you for Professor Dr. Martin Dolk for your knowledge, sharing us about realistic mathematics education. And that's all from us. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.